Thank you.
Yes. Now, sir, start the session or sir, wait for two minutes more?
We can start the session. How many participants are registered in this course?
Sir, actually 200 participants were registered. But in morning, 148, 149 participants were attended the first lecture.
Okay, no issue. So I hope that more number of participants will be joining very soon.
Yes, yes, sir. I have messaged in the WhatsApp group.
Okay. So should I start or need to wait?
Yes, sir. Yes, sir. Sir, we will start, sir. I think 1 o'clock is correct.
So we can start. We can start. Yes.
Okay, okay, sir. Yes, yes, sir. Good afternoon, all participants. In the second session of this faculty development program, at first I welcome our eminent speaker, Dr. Atul Gupta, sir, to this faculty development program on data science and applications and research direction. Welcome to you, sir. Before starting the second session, let me introduce him. Dr. Gupta is an assistant professor in computer science and engineering and head of the department of ITDM Jabalpur. He works in software engineering, machine learning, and NLP. He has guided many master of PhD students and published more than 50 research papers in various international journals, conferences. He is also a reviewer of many top-class journals in software engineering area, IEEE Transaction and Software Engineering System, Journal of System and Software, and many more journals. He is also recipient of Drona Award from IBM India from leading a team of students for software development competition CGMC 2010. He has received Best Paper Award in APSEC 2013. He is also one of the project co-principal investigators for Electronics and ICT Academy and coordinator Design and Innovation Center at IITDM Jabalpur. He is the author cum principal coordinator of Python programming course jointly offered by 7 ICT academies across the country. So I request Professor Atul Gupta sir to speak on his topic, that is the introduction to Python programming. Over to you, sir.
Yeah, thank you, Dr. Rasmi. It's my pleasure to be here and interact with my fellow colleague.
Yes, sir.
This course is on data science, its applications and research directions. So it's a very fantastic course. I love to work in this area. We are working many research problems which falls under data science, AI, or machine learning, NLP. And this is really exciting to be here. And I hope that many of you, I hope that all the participants are the faculty participants. So many of them probably looking after the research problems, right? They would like to do their research. Maybe they are already PhD, or they are pursuing their PhD, or they would like to go and pursue PhD in the area of data science or machine learning. So I hope that this course is going to be useful to them. And the job that I have been given by the organizer is to provide you a crash course on Python. So basically what we are going to do is, like in this afternoon, we'll have 2 sessions where we will be discussing about how to use Python. Even if you have no idea about any programming language, I will start from very, very basic. And we'll try to take you to the point where you can start understanding Python program. And you can start on this, taking some program which are already available and can run those programs, can make some changes in those programs, and can again run that program to serve the purpose. So the best idea about the Python programming is that it is a favorable language. In fact, the most favorable language as of now for data science, machine learning, deep learning platforms. So if you want to pursue your work, you want to do research in the area of machine learning, data science, I can tell you like this can be one of the very useful and very efficient tool for you to quickly get into the field. And I can also assure you that this is not the kind of language like unlike C or Java, where you need to learn the language first, maybe like a full course on Python programming, and then you get your hands dirty on doing those programming for some time, like 1 month, 2 months, and so forth. And once you got hold of that programming language, and then only you can use that programming language to solve problems, right? To apply and solve problems. But Python is a little different, and that's a good news that even if you do not have any background in programming language, you can learn Python in a matter of a few days, I mean 2 or 3 days, for the purpose that you would like to use it for solving some kind of domain-specific problem. So it's a very vast language. So if I'm saying that you can learn Python in 2 or 3 languages, don't get me wrong. The point is that the part which will be useful for your work can be learned in 2 or 3 days, and you will find yourself very comfortable. Otherwise, Python is a very, very big language. It not only just allow you to learn a general purpose language, solve problems, but then you can do more specialized tasks like, as I said already, that AI, you can design your applications in AI, machine learning, NLP, image processing. Not only that, if you want to do web development, then also like you can use this Python, because there are nowadays like wonderful frameworks, the software development frameworks like Django, which allow you to quickly like develop web applications also, and they are very state-of-art kind of web application that can be developed using Python. So in that sense, you can understand that the Python is, and even if you would like to work in the area of, let's say, IoT, and you would like to use Raspberry Pi to design your some solutions where some sensors are there, actuators are there, and you, with the help of Raspberry Pi, want to manipulate these data and control some devices, you can do that again in Python. So Python is like so much of usefulness that has come over the last few years. And I hope that this path, it's getting popular and popular, and I'm very hopeful that for next 10 years, I mean, this Python is going to stay here. So there are languages which may come and go, but I can tell you like Python is such a nice, such a user-friendly, such a easy to learn language. The learning curve is very, very small. You can quickly learn whatever the domain you would like to apply the Python. You need to learn that part of the Python only, and you can get going. So I'm sure that if you already know the Python, then whatever I'm saying, you are already aware of. You already can confirm the same. But if you're not aware of, if you're not that good, I mean, you have some idea of Python, but not good enough, you will see that, yeah, you can quickly build upon your initial understanding of Python language, and we can quickly start solving a little bigger problems and more problems, and problems, but specifically to data science related. Okay, so let me share some slides. I will start with though I would like to continue quickly come back to the code part, because it's a programming course. So best part will be that the programming language can only be learned by doing it. There is no way irrespective of how much slides I can show you, how much hour of slides we can be discussing, but unless you make your hand dirty, you cannot learn any programming language. So the same goes with the Python. And the best part is like we can learn quickly Python. Yes. So I hope that my slides are visible. Yes.
Yes, sir.
Yes, sir.
Okay, thank you. And regarding your questions, I mean, you can type your questions on chat box. So as and when I would find time, I would try to answer them. And I can tell you, like, this course is going to, this part is going to be very down to earth. I mean, so most of the things, the way I am going to navigate through the concepts of construct of Python, you will understand very quickly. But still, if you have any doubts, you can write your doubts on chat box. So there's some disclaimer about since I would like to create a nice set of slides. Sometimes what I do is like I got these images from various sources or internet and other. I try to ensure that I'm not violating any copyright, but yes, if it is there, then you can please let me know that if some violation is there, and I can update my slides accordingly. So this is just a disclaimer in which I put on my slides generally. So the assumption for this part of this course is that we will discuss that how to solve problems by writing programs, obviously in Python. And I'm not assuming that there is any prior exposure to programming that you have, right? So even if you are very new to this programming world, or you know, let's say C programming or Java programming, I can tell you, like, in these 2 sessions itself, we will be comfortable, you will find yourself comfortable with Python and doing small coding that you might have already done with language like C or Java. One thing is like just C is a procedural language, as we know, and Java is an object-oriented programming language, as again we know. So what about the Python? Python is basically an object-oriented programming, but the beauty of this language is that you need not to aware of object-oriented concepts to do programming. So even if like it's an object-oriented language, but you don't need to know all those object-oriented concepts to get going. I mean, you can learn a lot part of Python programming without knowing the object-oriented concept unless you want to get into the software development and other field. Then we require that you to know object-oriented concepts and the way the language is structured as object-oriented. So don't worry about these kind of things for at least for this session. I mean, these 2 sessions. Once you find yourself comfortable, I mean, you can see that you can yourself either navigate to the object-oriented part of the Python, or you can do some, again, a small course on the way the object orientation is incorporated in Python language. This has been already introduced, so I will skip this part. Right. So obviously, the question that will come when you do computer programming is, what is a computer, right? And when we say the computer is like, we get an image of like there is a desktop, where the monitor is there, or a laptop, right? But then not just these are the computer, right? That's fine. But then you know that your mobile is also a computer, and then there are toys and like other devices which have their onboard computers, whether they are car or aeroplanes or these washing machines or oven. These are all like basically in some sense like they are computers, right? Because computer is a device which can compute. And compute, when we say computer, is like the computation is performed through set of instructions, and generally we give them those set of instructions in some programming language, right? So that since these machines or these computers have their own languages, and that's why we need since these languages are difficult to learn, that is the machine languages, and that's why what we need to do is like we need to give them instruction in some high level language, the language that we are familiar with, the similar languages, so C, Java, Python or so, and these are translated to the machine language, and they get like executed on those platforms, on those computers, to get the intended job done. Right. So you know that nowadays, like, computers are everywhere. So how do you deal with computers? You give instructions to computer, and the computers are like just like an honest servant. I mean, it will carry out your instruction very honestly, very with high integrity, and with high repeatability, and you get your job done again and again, and same job done. So what is this is giving instructions? Instruction is like, so you will be writing this set of instructions, and this set of instructions that we call as program. So basically, that is how we do programming, right? We identify that what task to be performed and how this task will be carried out. So what instructions are to be given. All those instructions, when grouped together, that will be called as program. So when we solve a problem, we have a problem description, that the way this problem is there in that domain. And then we understand that how this problem can be solved using by writing some programs. But then this is not a very straightforward idea unless we have a good understanding of that what is a programming language, or how we can write those instructions, and how we can organize all those instructions in some kind of sequence, and the kind of instructions those has to be given to get the intended job done, right? So it looks like a simple idea that we have a problem description and we can write a program, which is nothing but a kind of code, right? So we use the term code, is nothing but, again, the instructions written inside the program. And you know that that's not very simple idea. What we do is like, first we need to understand that when we have this problem in our hand, how can we model this problem in a way that it can be solved by a program, right? So when we try to solve a problem by writing program, we need to have some kind of mental model, right? Sometimes we can create explicit models using pen and paper, right? Which we call it like flow graph or flow chart, or maybe some more complicated artifacts like UML diagrams, which help us to like first understand and specify the problem, and then with these specifications that we create, right, of this problem description, we then take it to the place where we can write the code for it, right? So the coding is not a at once kind of activity that you see a problem and you can start writing the code. That's not a good idea. Obviously, for very, very small elementary stuff, this can be done. But in general, when we solve problems by writing programs, we need to first design those programs. And designing those programs is about like first come up with a model of the problem itself, which is a kind of abstraction, which extract out the problem from the problem domain, and then you got some clarity that what is in and what is out. I mean, what is the scope of your problem? What are the elements of those problems? And then with your understanding of the programming construct and those idea, you try to map what programming construct map to what part of that model. So that's like some kind of like mapping problem where we create model of the problem, which is not the program design. But then with this model, what we do, we try to design the problem that we may call as logical solutions that may be independent of any particular programming language. So what we are talking about is like, still the problem is in the problem domain, right? And we have, I mean, there is no programming concept that applicable here at this point of time. And then we create model, and that model is also like a program independent stuff, any particular language independent stuff. Then we create a logical solution. Again, this logical solution, in some sense, we can call them algorithms. That this is how we can in a step-by-step fashion can solve, can meet out the challenges of this model, right? Can implement that kind of model. So logical solution, and then from this logical solution, we go to the code, right? So typical more complex problem that we solve using programming, I mean, requires some kind of like understanding the problem, modeling it from an abstraction point of view, that you know that what you need to take care of and what you need not to take care of. So that will be nothing but a kind of abstraction of the problem in the problem domain, which we can call it model. And then from the model, once we identify that this is the task that we need to carry out, how we will carry out this kind of task. So we provide a logical way of carrying out that task, which is nothing but will become a logical solution, step-by-step solutions. And sometimes it's also called pseudocode or algorithm or a family of algorithm. I mean, depending upon the size of and the kind of problem that we are trying to target. And then we convert this logical solution to the code. So this process of converting the logical solution into the code becomes slightly straightforward, in that sense that once you know that how we can solve this problem, right, then it's nothing but like mapping of that solution steps to the programming steps, and you get the code which will be executing, right? And many times with experience, you will find that these boundaries or these kind of different steps, they merge together. And once you become a experienced programmer, you will start looking at the problem, and you can maybe quickly converge to the kind of code that may come. But then it will happen definitely with the experiences, right? Initially, we try to identify them separately, try to understand the importance of each of these parts and how these parts are connected to each other. And gradually, these boundaries will be blurred, and you will be able to solve very quickly any problem, right? At least the simple problems and somewhat like a little more complex problem can be solved, though much more complex problem will require, again, the same kind of like sequence and cycle, that you need to first have a model and then have a design of that solution problem, a solution, and then you will going to code that in the solution. When we write programs, then obviously we take help of something which is independent of program, which is called algorithm or flowcharts. They're very useful because inherently you will see that programming is nothing but writing instructions. And these are basically sequence of instructions, and each instruction is doing some job, right? Has some role to play in that sequence of executions, right? Ultimately, when you will run your program, all these instructions will be executed in that particular order in which you have returned your program. So if you leave out the intricacies or complexities of programming language, because programming language has their own syntax and structure, semantics. So, and there are so many programming languages. I mean, maybe you may find like more than 10,000 programming languages, though some are more popular than other. Yes, but then all of them are having different syntax and somewhat like semantics. So it's difficult for a person to learn all these programming languages, obviously, and the new programming languages will come. But then for a solution designer, what is the best idea? Best idea is that they should work out the solution without actually looking at any programming language per se. So their solution should be independent of any programming language. And that's where this idea of like flowchart or algorithm comes, which helps us to design a solution without actually focusing or bothering too much on the what kind of programming language we are going to implement that. So when we say now algorithms, so basically algorithms are nothing but is kind of abstraction of solution, right? So it's like a step-by-step way of solving the problem, and that step-by-step you can write in your natural language, right? The language that you're familiar with. You don't have to, I mean, you can use your mother language. You don't have to use any programming language. So the algorithm makes our job much simpler, that anybody can read this algorithm because they are written in some natural language and can analyze this and can refine that before actually you convert that into the code. So just like there are many things that we do on a daily basis, right? Like we cook cake or make teas and those kind of. So you know that there are steps involved, and all these steps are to be taken in some sequential, some sequential order, and at the end of like all these steps, you get the intended results, right? Coming to Python. Python is undoubtedly like now one of the most popular programming language. I mean, the big companies, all those big companies, they are using this Python, whether they are Google or Amazon or NASA or any other company you name, they are all like using this language. And there are lots of like platforms and sites are being also using this Python. I mean, you will find that social networking site like Instagram, Reddit, Quora, they have been designed using this Python as a Python framework. These sites have been designed. These are typically web applications and has been designed over Python. And then the companies like Netflix, they are also using it. And there are many companies like so. It's I'm just not suggesting that there are AI companies also. I mean, AI in healthcare, AI in transportation, in agriculture. They are also using like Python large extent. So there are some codes which we can again emphasizing that why the Python has become so important, right? There is some history to Python. I will go through a little quickly because we will try to have some hands-on. And I'm going to share you the code also, which you can do in in parallel with me, and we can learn together, right? So there's history which like the inventor of Python is like Guido von Rossum. Like he created the Python first for dealing with server-side programming, but gradually the idea becomes so prevalent that it was like it has been so simple to like write the script at the then the people really like worked out to make this as general purpose language. There are many reasons for why to use Python, and I would just suggest you to just write this, that why to use Python and why Python is so popular or so and so forth, and you'll find that this internet is will be flooded with lots of like argument regarding that why you should be learning Python, right? So this is for me and for people like you. The most important thing is like it is easy to learn, and it's a simple language. But then it is not. If it is easy to learn and simple, that maybe it may not be powerful. But then this is not the case. It's a very powerful language. It's a very lots of features, lots of like way this programming language can be used to solve problems. The readability is high and maintainability is also to quite extent is is good, right? So Python is easy to learn, easy to maintain, easy to like comprehend. So why not? I mean, just think about, like, we have got these three examples. So this example is about, like, this is a program written in C, right? And this is a program written in Java. What this program is doing, they are simply printing hello world. So you can see, like, we got this C code. This is the Java code. The purpose is to print this hello world on your terminal, right? On your console. So, and what intuition that you should get when you want to print, you want to get this hello world displayed. I mean, just one command and you get this displayed without actually having this 5, 6, 7 lines of code with such a structure to understand what is main and strings and arguments and what is this system.out. Just think about it for a new person, right? How simple is this idea that this is the Python statement to print hello world. There are many other reasons. I mean, I have included in the slide. I mean, it's covered full data science task cycle that you can. So since this course is on data science, I mean, whatever task that we do as a part of data science, whether it is we are acquiring data, performing pre-processing, and then performing some sophisticated data analytics, or more sophisticated algorithm, applying some more sophisticated algorithm like machine learning, big data processing, or high performance computing. I mean, whatever you do, I mean, you can do that, all those tasks in Python. So that's what the argument is, like, it covers full data science track cycle, right? It's an interpreted language. So this is an argument, like, why, I mean, whether it is good or bad, it's an interpreted language. Like, that means, I mean, you can execute program one statement at a time, right? So debugging is going to be easier. I mean, if you have, like, let's say 1,000 lines of code, and if you want to, if there are some bug, if you run this program, all those 1,000 lines of code will be run if it is any other program. But then in Python, you can actually run this step by step. Though there are, for other language also, there are additional tools which will allow you to run or execute the program in sequence. But this is inherently, it's like an interpreted language, right? So we also have the compilers for Python, which can all at once can execute all the code. And another aspect that you will see more often than not, that when you write some code for solving problem, you'll find that you're writing small code compared to other languages, right? And we have seen this example that you would like to just print hello world, and it's like one statement without any complications, right? Any specific syntax or semantics. But in other language, if you whatever you would like to do, you take some good amount of code. There's another very important, very powerful aspect of Python is that it comes with a huge library support, and it is getting further enhanced day by day. There are many open source Python frameworks, library development tools, which you can use to solve your problem, right? So that's something which is called as not reinventing the wheel. That if somebody has done it correctly, completely, some part of like problem solving, that he or she can share that as a library, can create those libraries, and any other person like us, any other person can use these libraries, and you don't have to write all this from scratch. Hello.
Yes, sir.
Any question? I got some. Okay, no issue. I thought somebody else has asked some question here. So it comes with the huge library support. for all kind of purpose, like whether it is you're working data science, we'll see that what library we are going to use. And if you want to do web development, then also like you'll find that whatever purpose that you would like to work on image processing or computer vision, NLP, you'll find a lot of useful libraries. I mean, these libraries are nothing but the functions, set of functions in the form of like Python code itself, so that you can reuse this function, this code in your main program. You don't have to write them from scratch. So your code is going to get smaller and compact code, which you can see, you can troubleshoot, you can make changes very quickly. So this actually helps us to like improve our productivity a lot. So that's why Python is considered one of the like language with very high productivity. That is, a developer who use Python can quickly develop any particular application, right? Compared to if that developer works use any other programming language. It has better business prospects, future business prospects. As I already said, that is an all-rounder programming language. Whatever work you would like to do, you would like to create web applications, desktop applications, or games. I mean, in mobile application, it's not very much there, but then very soon you will find that there are mobile interfaces through where you can program in Java, and you can create wonderful apps also. And games, or you want to search net or collect data from the net. You want to create visualization, powerful visualization. You want to control hardware, as I said, like Raspberry Pi. You can write programs in Raspberry Pi using Python. And so that's why it's an all-rounder programming language, very versatile language. And the good news is like it has great corporate sponsors like Google, right? So you know that Google probably the topmost company in the world, right? And they are using Python to a large extent for most of the work that they do for their research and for their development. They're doing it in Python. So it's like quite a big backing which is available with this Python. And you know, like 8 out of 10 top 10 US universities CS program have adopted Python, right? So you see, I mean, for like say 5 or 10 years down the line, they were teaching C language or Java language, but they have moved to Python. I mean, so they teach their students in first year Python. I mean, there are obviously some pros and cons when we discuss about which language to be used as a first language for our engineers, for the beginners. But you can see the trend, the way it is going on. So there are arguments and counter arguments, but still there is a huge favor towards Python. And in India also, like in many IITs, like they've started using, including in our like triple IT also, like we have introduced Python in the first year, the first language for our engineers. Right. So highly portable. That means your code written in one place can run any other place. It's something like which Java enjoyed a lot, but our Python also enjoy this thing. It is compatible with major platform system, right? And the best part is like it's a free, open source, and all those like libraries also. You'll find that most of them, almost all of them are like open source, or they're free libraries. So quite a large amount of thing, or many amount of things that can be done, right? So when you write a program, what you do is like you write some part of code and you run that code, and if it provides the intended results, intended outcome, then you say, okay, you're done for that part, and you go further. Or if it is not, then you probably see that what part is not correctly working. So you do some kind of debugging and then run it again, and then maybe you would like to check it on different kind of inputs to see that if it works for some input, but it may not work for some other input, right? So that is interesting aspect of when you write code, and then you would like your code to be correct, right? Your code is quality code, right? It is correct. It can behave correctly on all possible input. It's a difficult proposition to show that if a particular code is correct and it can produce the correct output on all possible input, because all possible inputs can be infinite. So it's very hard to check for all those all possible input. And there comes the role of testing of program, that we would like to like test that program. Testing is nothing but to execute that program with different inputs, again run it and with different inputs. So we will run this program with different kind of inputs every time, and we'll try to see that if it provides the intended response, the correct response. It doesn't produce as incorrect response or doesn't crash as, so it doesn't show any unusual behavior. So the testing, the purpose of the testing is to ensure as much as possible that your program is correct. And since we cannot test a program on all possible input, so that's why the testing is an important idea, that we have finite time, finite resources. So what inputs that we should give, and for those input, what output should come. So they are nothing but this input-output combination. They are called test cases. And these designing of these test cases and running and executing them, recording the failures, and again going back. And so this comes under like testing and debugging set of activities, which are equally important to ensure that whatever code you have written the correct code. Regarding the Python programming platform, that where you would like to write your code, Python programming code, there are many editors or standalone platforms. Like for example, Anaconda or PyCharm. These are like complete IDE, which is like GUI based. So very nice GUI and based this IDE. IDE stand for Integrated Development Environment, where you get all the important component when a program run is to be available there only. So all these things comes with this Anaconda IDE or PyCharm, and there are others also, right? For example, we have Visual Studio Code. That's like Microsoft is also like working very hard to project their VS Code as an open, like free editor, as well as IDE, so that you can use any language. You can use Python and you can write your program, and a lot of help that is provided over by this IDE, where you can organize your code, you can write your test cases, you can add more different kind of files. So you can actually do a complete software development using this kind of IDE. So these IDEs are useful, though we are not interested to develop a software per se in this course, but I can tell you like there are all these platforms which are available, and all these are free of cost. You can use them. Now, what we are going to do is like we are going to use this Google Colab platform. So this Google Colab platforms, I mean, why Google Colab? I mean, very soon it will be very obvious that it's so efficient, so simple, so accessible that you can quickly write your code and can execute that and quickly build your code. So for our programming purpose, we are going to use this Google Colab. I'm now going to this platform. This is from Google, and wherever you are, I mean, you also have access to this Google Colab. So I'm going to share this Colab notebook files, which is nothing but the code file, and we will be able to see that there are some simple code, and we will try to make some changes in that code. We'll try to run that, and we'll see that whether it is like correctly executing or it is giving some error, so that all this kind of information will be instantaneously available to us, and that can greatly enhance our learning aptitude and learning skills, that you can quickly build on your code, quickly get your concepts about like using some like particular kind of Python statements, that whether how to use that Python statement or that functions or that kind of construct, right? And if you want to use some libraries, you can import those library and use those functions and can write your code. So all these things we can quickly see when we will go there. And a very similar kind of like notebooks are Jupyter Notebook, which are part of Anaconda ID, but we are going to use Google Colab, right? So let's go to Google Colab, right? And let's start making our hands dirty. So what I will do first is I'm going to share the link of this file, this code files, which is Colab files basically, right? So I will share those with you so that you can not only have access to all this material which is relevant to this part of the course, there are exercises also which you can do. So it will be very useful resource for all those who would like to learn very quickly, right? So here, I'm sharing this link to everybody. So this is the link which I have shared on chat box. What you do is like you can click on that, and this is a link of folder where we have got all those relevant code files and the other resource files which are also available. So basically, it's a link to a folder which is on Google Drive, and I hope that all of you have like a Google Mail account, so you can access this Google Drive, and just by clicking on those files, I mean, I can show you how to do that. That will be very straightforward. So let me share. Let me stop sharing. And now I will share the whole screen. I'm not very good at Google Meet. Sorry, WebEx and Google Meet, because we use Zoom. We have got like this corporate license of Zoom, so all of us here, IIIT, using this. So slightly, sometimes you get confused, like when you would like to share the whole screen, whole screen. So probably let's see if it works. Can you see this screen where all those files in that particular folder is being displayed? Okay, good. So yes, you are able to see that. That's great. So you know that there are a number of files. Don't worry about that. All of them, I'll tell you that which file to use when. First, we are going to use this Python programming -1, right? IPython notebook. IPYNB stand for IPython notebook. And it's a very interesting format of visualizing your program. You'll find it's a web interface to Python programming code. So you can see your code, and it looks like it's a browser interface, right? So there's something very, very interesting, because this allows you to like use clouds, just like Google Colab also, like it's a cloud platform, and you are running your program on the Google Cloud. So you don't need any Python to be installed here, or anything special to do to learn Python, right? So what I'm going to do, I'm going to double click it, and it is going to open this, because I'm in the Google Drive, so it knows about that what kind of file I'm opening. So it by default, maybe first time if you're opening, then it will ask for that whether to open it with the Google Collaboratory. You can say yes. And then after that, whenever you double click, you're going to get this IPython notebook open, right? So I hope that you can see this Python-programming-1.ipynb open in the Google Colab. Yes, on my screen.
Yes, sir.
Okay, good, good. I mean, just confirm it. I mean, you can write a chat message also. That's perfectly all right. And you can see it's, I mean, obviously, if you're a first timer, you may require some time to understand this interface. But then again, I can tell you this is one of the most intuitive interface that we typically Google provides. I mean, we are all used to use Google applications like Google Doc, Google Drive, and other things, and you will find that they are very, very simple also. So here, this is the file, right? Python programming -1.ip, and that is open here. Now here it is IPYNB. It's not .py file. It is .ipynb. Right. So there's like pure Python file will come .py file. Right. But then this is .ipynb. So this is stand for IPython notebook. Actually, if you look at, I mean, try to read this in a text file, you'll find that it has some those HTML code also, like in that code, which is embedded with the Python code. So since we want this code file to be visible on browser, right? So that's why the browser is like, you know, that browser deals with HTML files. So that's why, I mean, you'll find that the underlying code of IPYNB file is kind of like HTML file. But at the same time, I mean, all these like arrangements here where we can write the code, we can write the comment, they are quite like I mean, very, very intuitive to understand that how we can write our code here. So here you can see we have got like some menu items, just to forget about for now. We have got this two further menu like code and text, which is you can either add a like code fragment or a text fragment. Now when we say text, this you can consider as a text fragment. Text fragment is typically for you to document something, right? Writing comments, writing titles or subtitles, all those information, those you would like to like make them available for your reader to understand. So that's like text part. And the second part is like code part. So again, this is a very straightforward idea. You see, we have got this is one code part, right? Just a minute, we got. So you can see like this, we have a like code here in this particular part, and then we have some more code here. I mean, in the here also, and the lower in this file, as you go down, you will find there are many code fragments which I have included, and along with the text also, right? Now the interesting part of this IPython notebook is, as I said, that you can sandwich your code with text, right? So this is code, and this is another code, but then this is text, right? And this is title of this whole file, right? So we can have like by looking at this, we can understand that what this code is about, right? And we can write more comment, more text and more comments also. That we'll see that whenever it requires or that need to be served some purpose. Python starts here, and I promise that it's going to be a good session in introduction to Python, right? So for those who, in some sense, like would like to go through the introductory session for Python, I can promise that this is going to be a very good session, right? Now, when I am using Google Colab, please don't get me wrong. It's not that for the most simple or easiest way we can write our code. And that's why, because it's basically a kind of teaching or learning session. So I'm using this particular IPython notebook, Google Colab, and it's just for academic purpose only. And it's not. I mean, when you go and write real programs and want to like solve some problems, you probably using uh, some other platform. But this is not true. I can tell you, right? This platform can be your first and last platform where you can not only learn about Python, but you can also solve problems using on this platform itself. So you're not going to, most likely, you're not going to get away from IPython notebook. I mean, this Google Colab. You may use it for all practical purposes, for your initial learning and for your advanced application of Python and solving problems. That's perfectly all right. Though there are other platforms also, and they have their merits and advantage, disadvantage. So depend upon that what kind of work that we would like to do, we can switch. We can move to one platform, another platform. But for all your most of the purpose that you would like to serve, you will find that this Google Colab is good enough for you to satisfy all your requirement. Most of your requirement, I would say. Right. Second thing is. This whole file, IPython notebook, is divided into cells. So this is one cell. This is text cells. You can see here, whenever you want to add some text, you can write some text with some hash here. I would suggest that what do you mean by this having hash here? And then this is the text, right, that you've written. And as soon as, I mean, just escape it, and you will see that this text is displayed. But if you want to edit, just double click this and it will open. And what it suggests that this is the text. So here you can do all the changes on this. This is the editor, text editor. And here it shows that when you make changes, how it is going to get reflected. And then press escape and you will get this as completed, right? Again, I double click it. And if I put another hash here, I mean, just for the sake of like how you would like to have your text getting visualized. Now you can see like it is getting slightly smaller, right? So earlier it was with a larger size font. Now this time it is smaller size font. So it's just a right. How do you would like to? I can put one more hash, and it is going further smaller. So depending upon, I mean, you would like to have sections, I mean, headers, subheaders, or sections, subsections, subsections in your this kind of nicely organized Python code book. You can use these kind of things, right? So what I'll again remove these two hashes so that I will get this title, which is the biggest font size on this Python notebook. This is another cell, and you see we started with that when we would like to write something, right? So how you would display anything? So so I would like to write my name, right? And if I run this, I get this like there's two print commands, hello world. And then second, I'm using double quote. So in so you can see like in the first line, I have used single quote, hello world, and in the second line, I've used double quote. Now, interestingly, I mean, though for programming languages, these are very subtle kind of syntax. And if you make some error, I mean, if they require, let's say, single quote, and if you provide double quote or vice versa, you're going to get error, right? But Python developers or Python designers, I would say, those they have from the beginning they have kept this idea very simple and straightforward. That whatever we would like to our user, our developer, our coding persons or programmers, when they will be using it, it should be most intuitive to them. I mean, it should not sound like very ridiculous or something which is like need to remember. So this coding should be as much flexible as possible. So you can see like whether I put a double quote or single quote. Now you can very well say that why to put quote. Well, I mean, it can be even much simpler. Just put hello world, right? And it should be printing. But here it will going to give me some error, right? And what it's saying, the syntax error. So syntax error, I mean, obviously Python is another programming language, and any programming language that comes with a syntax error, right? There are syntax error. Syntax errors are nothing but the structure related error, the statement structure related error that if you like doesn't use the correct structure, correct syntax, then it is going to give me a syntax error. And that's like that. That's what we got here, a syntax error. So I can put, let's say, back this single quotes here. Now, why this is so? I mean, one can say that okay, when it is we would like to keep it simple, then why not? It is so simple that why to put a single quote? So gradually you will understand. Those who are familiar with programming, they already know the answer that we will be dealing with different kind of data set, the data type, different kind of data type, and here this hello world is basically is kind of a string data type. I mean, some kind of character strings that we would like to display. And then we can have some like the other data type like integer, boolean, floating point, or real numbers. So typically in programming languages, we deal with different data types. And therefore, to differentiate that what kind of data type that we are targeting at this point of time, so that capture our intention and correctly execute. And that's why some syntax has to be provided, and that's what the reason is. Like you can use this single quote, though they provided flexibility that you can use double quote also, and we don't mind. You give it in the single quote or double quote, we are going to run it, and and these are nothing but these two strings will be printed. So it's a this idea. I mean, this is a simple idea. And you will see that this idea is throughout will be reflected in Python until unless some fancy stuff needed because of to differentiate between the kind of use, or I mean to make it very clear that what is the purpose of using it. Then only we will find that there is some provision. Otherwise, you will find that it is more or nothing but like mostly capturing your basic understanding, your basic intuition behind that, how we should be using a particular statement or writing that. Right. Okay, so let's go. So this is, as I said, this was a cell here. This is code cell 2 statement. You can write 10, 15, 20, 100, 200 programming statement here. You can also write comments also. So comments is like non-executable statement. Comments, as you know, many times we would like to suggest that what this code is about. So the most basic code. So when I am writing a comment here, this is a non-executable piece of code. I mean, this statement is not going to get executed, right? So this is just for the sake of reader, right? Improving the readability, making it clear that what this code is about. I mean, for this trivial thing, you don't have to write anything here because that's very straightforward. You know, don't need to know more details about that what this code is going to do. So you don't provide any comments here, but gradually as you will start writing more complex code, you will yourself will figure out that yeah, maybe 10 days, maybe 15 days or month later you come back, you may forget about the kind of logic that you have built in that code, and therefore you would like to recall that. So by simply playing with the code is not a good idea. It may take a lot of time before you understand that what you did last time, but having 2, 3, 4, 5 lines of comments may help you quickly figuring out that what you did and why you did and what is the purpose of that. Commenting is considered as one of the best practices when you write your code. So though it is not an executable code, so it doesn't count on the productive code per se. Productive means the number of lines of code written by you or the size of your code. It doesn't reflect, it doesn't add the size in that sense, right? But then it makes your code very useful, because in the industry, people leave for other company when they get better offers. So somebody has written some code and then the person leave, but then the code is not to be abandoned, right? Somebody else will take charge and will build upon that code. So how they can do it unless that new person knows about this code. Now, how you will know about the code? So these are the things that is very important to get it documented. So commenting is very, very important thing. In industry, you will find that they write, if they write 100 lines of code, probably there are more than 100 lines of code, 100 lines of comments that might be there. There. If you are interested, just see the documentation of any programming language. For example, go and see the documentation Java, Java code, and you will find that the code is of 10 lines and the comments that they provided are of like 20 or 30 or 50 lines. So something is like very, very relevant, though it may not sound at this point of time, but gradually as your programming experience will enhance, you will understand how important is these comments are. Okay, let's move further. So this is one coding cell. You can add more statements by writing them or delete them, whatever way. So this is, you can say one placeholder where you can write the code, and you could quickly check the code whether this code is running or not. So forget about there may be 2,000 lines of code in this file, and all are doing a lot of fancy stuff. But then if you are focusing on some particular part of, and what you can do is you can just run that particular cell. Only thing is you need to know about that if there is no dependency between this cell and any other cell previous to this cell, because you might have declared a variable in some previous cell and you might be using it in this cell. Then there may be a problem if you don't run that particular cell and then instead you run this directly. So those kind of things you will understand. These are very simple things. But yes, we can write our code in very small chunk of code, manageable pieces. So you don't have to write all 100 lines of code or 20 lines of code, and then you are struggling to get it executed, get it running correctly. Just write one line or two line, right? And you will be, comfortable when you say that, okay, the three lines are correctly working, you can add two more lines and so on and so forth. So your code can start building, becoming larger and larger size. And when we'll discuss some more useful idea like functions, you will find that we can further organize our code. We can write code in small functions, right? Many functions, let's say you can use 10 functions, 50 functions, and your main code is going to be just using those functions in one statement, each function in one statement. So your main code is going to be get smaller and smaller. So, and though you might have written 50 functions and each might be taking, let's say 10 lines, so 500 lines of code in those functions, but your main code is 20 lines or 30 lines or something. So something is with the code organization, which you need to learn, that when you write your code, how to organize, so that not only for you, it becomes efficient to understand, to organize, to troubleshoot, debug, right? Understand the design, but for other also, it will be equally straightforward, right? So let's go to some more cells. So here you can see I have some more print statement. I've shared this file, so what I suggest all of you to open this Colab file, this IPython notebook file, which is python-programming-1.ipynb from the link that I've shared. Open it, run those cells, and when you will read these programs in sequence, right? I would say that each of these are programs, right? Though we are not giving some separate name to them as .c or .py, but then that is the best part of Google Colab, that we don't have to bother about giving names to each of these files. Rather, they are stored here in this file as cells. They may be independent cells, they may be dependent cells, depending upon what kind of code and the connection in the code that you would like to have. But whatever, like it is all like it can be managed within the Google. So here you can see I have some more print statements to get yourself familiar with the printing part. That when you use this print statement, it displays certain that message which is passed as a parameter, right, to this function. So basically, print is a function. You can see straightforwardly we have started using a function, but this is an inbuilt function. Inbuilt function is like, that means we haven't written the code of this function. We are the user of this function. So we are directly calling this function by naming this function and passing its parameter argument. So whatever is inside this small bracelet, they are that whether it's one thing or two things or three things, gradually you will see that you can have any number of things as you will design your functions and you will be using those functions. So depending upon that, what kind of arguments, these are called arguments. Arguments means this takes inputs. You know, these are the inputs to this function. So in a sense, like it's a very interesting and very like standalone kind of program unit where this function print takes some input, which is I like MIB4, right? And it does something, right? So a function, typically in programming language, what it does, it has a name, it takes some input and performs some processing, do some processing, and produces some kind of output, right? It can return the result of the output, or it can make some changes somewhere, may not be returning anything. So it's perfectly all right, but the function does some useful thing. And the whole code, I mean, when you think of like designing a solution for a bigger problem, you can think of like dividing that bigger solution of that bigger problem in small part. It's called like divide and conquer approach, right? And then you solve this each of these divided part, and when all these parts are solved, maybe probably you combine them some sense and get the solution of the original problem. So this divide and conquer approach is very natural approach to humans, right? We are used to it from since our childhood. We have learned this idea of like when we have some problem in our hand in front of us, we figure out that okay, we need to do three things or four things or five things. I will do this and somebody else will do this and so on and so forth. So, and then we can exchange some information. So you see, this idea of solving problem is very natural. And in programming also, we are going to make extensive use of this idea of divide and conquer, right? The big problem divided into small problem, and these small problems are further divided into smaller problem until unless we are convinced that this particular small problem is not to be divided further. And therefore, you may have a number of small problems, and there's some kind of hierarchical decomposition of the problem where each part need to be solved separately, and then the solutions will be combined eventually in some fashion, and we will get the solution of the original problem eventually. So that's the divide and conquer approach, and that's what we typically do when we solve bigger problems, and you will be doing it. Here, in this cell, we have some print statement. No divide and conquer required here, don't worry. You can run those code. So you can see like some comment, some code lines I have commented. You can remove this by deleting this hash from this. So when you delete this, they are ready to get executed. And if you put hash, that means you are explicitly asking them to not to get executed when you will run this program. So when you run this program, these three middle statements, they are not going to get executed. But the first one without hash is going to get executed, and this last one also getting executed, right? Now, if I uncomment this statement, print this line, you can understand now by yourself. There is some issue. There can be like, because you have like this code started here, and then can't is a word, but then it comes with a code. So, I mean, what is going to happen? I mean, this is very interesting. I mean, computer programming languages are not that intelligent to understand, though we are moving toward intelligent programming, but still Python, their Python is not that intelligent enough. So when you run this, you'll find that it will complain about. And why it is complaining? Because it is understanding that this part is the string, that is fine, the string is, but after that, this T is creating a problem, and then there is a quote without an unquote, right? So you see, when there is a quote, it should come with an unquote eventually. So this is the starting quote, and this is the end quote, right? And then we have, again, in between, we have another word in quote unquote. That's fine, because when code is started, so that has a correct structure, but this miss out on those structure, because when we start this, so up to this point, it's a string, but then after that, we cannot put it like this kind of things, right? And then there is a code at the end, which is like, so how can we do this correct? And there are ways to do it, and like in the next line itself, you can find that there's some way we can manage these kind of things. So yes, do some experiment from your side, so that you can get a feel of, like, when you write different kind of print statement. When you print, print is a very important function, because when you start programming, we will do small things, and then we'll try to see that what is the result. So when we try to see what is the result, we display that result as a print statement. Otherwise, that result will not be very explicit, so that you can observe. So if you want to get these results, observe some results which is computed inside your statements, inside your code, you want to get it shown, displayed, right? So you are going to use this print function. So that's why print function is very, very important. You can do you can take multiple argument. This is one argument, one string, then followed by comma, then we have a 5, followed by comma, then we have another argument, which is a string. Now, by this time, you must have understood that the string data type, the string kind of data, it comes with a quote and unquote, right? Whether double quote or single quote, that's fine. It's both are equally applicable, but it must have a starting quote and end quote. Then only this particular part is considered as a string data, right? Whereas this is integer data, and this is another string data. So you see, we are trying to print 3 things in one print statement, and that is fine. That can be done. You can print then this run that, and you can get this printed. Now here you may have some questions, right? Why we didn't put a quote and unquote here? You could have put this also, and you're going to get the same results. But the point is, like here, when this particular statement is getting executed, what Python compiler understood this data as a string rather than an integer. And if you intend to supply here an integer, you can, without actually putting the code, you can put it. And this kind of understanding is there in the Python, that if there is a number, that can be straightforwardly recognized as an integer, and you don't need any special things to recognize this as an integer, right? You can also see this is an argument, and argument can be an expressions also. So you can have like argument where multiple values are passed, right? You can pass an expression also. So how this will work, when the expression will be evaluated first, and then whatever the result will be taken as an argument for this print statement. So you will see that in many cases, like in Python, whenever you would like to use these kind of statements where there are some expressions are included, so the first expression will get evaluated, and then results of this expression will get substituted in that, and then the results will be displayed. So rather than having like 10, we can have like 10 and And if we would like to, so we will get 10, but then we have, what we did is like 5 plus 5. And quite intuitive, right? So what 5 plus 5 is not going to print me 5 plus 5. It is going to, because these two are integer kind of argument. So that's the kind of like, yeah, understanding is built in Python. You'll find that Python to some extent is quite sensible language, because it does what is most like mostly one has assumed, right? Human like us, we think that when it is 5 plus 5, so it should give me 10, and this is like it is printing. So it is not complaining like regarding that it's a syntax error or something, why plus is being used. Is itself is figuring out that 5 is integer, another 5 is also integer, and there is a plus sign, it's an expression, it's a valid expression, it will be evaluated. But if there is an incorrect expression, then it will complain. Then it will throw error, right? And there are examples included here. This in this cell, there is this code fragment suggests that how can you, have a bigger line can be partitioned into multiple lines in the code. So put a backslash, and still you can get all this thing printed. So I can put a backslash, and I can further write, how are you? I am fine here. And you see, it's nothing but it's a string. It started with a quote, and all these are within the quote. And then there is the quote which is unquote, right? So you can see like we have got the correctly paired quote unquote, and in between we have used this backslash to write this code in multiple lines, but that should not be a problem. So it's just a visualization that if you want to write a statement which is like going multiple lines, just put a backslash, and that will be taken care of. Now coming to the variables, right? So just like any programming language, they have variables, right? Variables and data type. So variables are basically nothing but the placeholder or the references where we store some value, right? So for example, we have this variable 1, and I am assigning this variable 1 as my name. My first name is Atul, right? So this is an assignment statement. So that's the kind of, you can see like this first kind of statement in Python is like this assignment statement. It's a very simple statement which has left-hand side and right-hand side and separated by this equal sign. And what it suggests, it is not mathematical equal, right? Mathematical equal, that these two things are equal. No. It's the assignment statement. Assignment statement means the right side of this statement, which is some value, or it can be expression which can be evaluated and will return some value. So this value, which is on the right hand side, has been stored against this variable. So whenever this variable, so that variable will become an address, a reference, right, or a name for this data. So this is the data. Atul is the data here, quote and unquote, single quote. And it's a string data, right, specific data. And what I'm doing is that I'm storing it. I'm storing to this variable 1. Now, when we say it's a variable, that means it right now it is storing Atul. Later on, it may store something else, some other name, some other string, maybe later on some other. So you see, that's why it's a variable, because it's not just storing Atul for all the time. It can be made store to all possible strings which you would like to store. So the only thing is, for now, since it is like we have given a Atul here, which is a string, so that's why this variable will become a variable of string data type. There's one thing which probably we haven't emphasized till now, that Python is a dynamically typed language. Now, what does it mean? That is, the type of the data and therefore the type of the variable is decided on the fly itself, right? As the code is getting executed. So right now, this variable one, we haven't declared variable one as a string data type. We haven't declared anywhere, right? We have straightforwardly used a data, which is string data, and assigned it to this var one. And this is dynamically typed. That means dynamically, I mean, on the fly, this variable become a string type of variable. You can just see the type of this variable. Just run it. So I have printed this variable. So when this variable holds this data is Atul, which is string, and the type of this type command or type function, which will take some variable or expression or whatever like you can give. It will evaluate that internal argument and will return you what is the type of that. As you know, Python is object oriented, as far as the information is concerned, we know that, and that's why this term class will always be popping up here, that the class of this data is string. But though we know that, okay, it's a string, right? So class, because it's object orientation, so that's objects and classes and those kind of things. And all objects or all data is nothing but some kind of objects or some kind of classes. So with the class of this object, which is a tool, which is a string actually with the specific type, is a string, right? So the class of this variable is also a string. So this is important. I mean, I haven't initialized or that variable one to be a string type. Later on, if I declare this variable one as 30 something else, right? If I say variable one, let's say 25, and if I run this, now it is changed to integer. You see, I haven't mentioned anything that what I'm doing. It is choosing this based on what is the type of the right hand side. So whatever is this type of the right hand side, that is right. So this is 25. So this is integer. I mean, this automatically by default assume that this type of this variable is. Okay, move to some next cell, and you see that there are some little more involved kind of expressions, or you can see like here we got var2 is 34, right? And let's say I put it in the text, right? So this is a string, and the type of, so this again I'm converted to string, and then this is 34, so this is integer. And you see what I'm doing is like I'm trying to add here. Now these two are basically string, right? Var2 is an integer, and 45 is also integer. Is there? And so this will not complain. This will not raise into any error. Both are integer. It will simply add these two by substituting var2 as 34. So 34 plus 45, and the result will be displayed here. What about this? This is also like find both arguments are string, and this plus sign is not just mathematical or the plus for adding numbers. It can also add to string. In that sense, the add function becomes like concatenation. So it will combine these two strings. So again, some kind of like sensible stuff built in Python, that depending upon what the two arguments are, the type of these two arguments, this plus behaves sensibly, right? So if there are two arguments are integer, it will add them, will output like 79 here. And if there are two a string, it will not complain that it cannot add. What it will assume that when you are using this with two string, I can join these two string and return this. But if you try to run this part, you see this is a mismatch, type mismatch, right? This is ABCD, this is a string, this 45 is integer, and we'll try to add this plus. Obviously, these two are of different type, it will complain, right? I mean, you may think of like कि यहाँ पे कुछ common sense लगा ले इसको भी 45 मान ले, string मान ले या उसको जबकि ABCD cannot be converted into an integer, but 45 is an integer, so consider this a string and add. I mean, for now, like this kind of logic, this kind of intelligence is not built up, right? So this is still like this, that the typical programming language, but some more sensible stuff that since you might be adding these two components, they may be of different type. And when they are different type, you might be having some intention, which you know, right? I don't know, so I'm not going to do a guesswork and will provide some answer here. No, I will complain here only. So that's what I mean, simple logic which has been like applied here by these Python designers, and this is how we got this error. You can convert. I mean, you can remove the error from here by typecasting. So this one way of like what I can do is like I can convert this 45 into a string. So what I'm doing is like I'm taking this 45, typecasting is as a string. That means I'm converting this 45 is the original data, whatever data is, I'm converting that to a string, and then I'm running this, and you'll find that it will not complain. So here the type mismatch, when we start programming and we'll deal with the multiple data types and their operations and all the other things, you may find sometimes your results are not coming and getting some error. I mean, you can quickly troubleshoot that and figure out that there might be some type mismatch, and that can be corrected, so you will get the results. Then in the next cell we got, so you can see like there's some small code, very small code, and you can add some more code here. And there's quite a intuitive platform where it encourages you to check. I mean, if you have some question in your mind, kya hoga ki if we change this in some way, right? Remove this code or add something here. Just do it, and you will find that if your intuition is correctly captured, I mean, obviously it's capture more sensible one. It will not. So you will, at the end of the day, you will have some rationale behind. Yeah, yes, if it is doing like that, yes, that is fine. And if it is giving an error, yeah, it sounds also like fine, because this is a confusing situation, and therefore you should be informed about that. This need to be corrected. So gradually, your understanding about these statements, about their executions, about the kind of errors that you get and why you got some error and why you didn't get, this will enhance your understanding of problem very quickly. Now, here in this cell, you can this is a length function. So there is a variable which can have some kind of length defined on this. For example, string has got length defined. So string is like number of characters. So it is going to print the length of that variable on that. Now you can directly pass a string also, right? You can put it text in quote, and it is going to give same output, right? So whether it's a variable which is like placeholder to store data, or it's data itself directly, or some kind of expressions which will be evaluated first, and then will be like used by the wrapper function, and then if it is done correctly, then you are going to get the correct output. Okay. Here you can see in this part, you got 3 variables ABC, and I'm assigning them 1, 2, and John. So you can see that is like multiple assignment, something which is interesting and normally not available in another language. And in one line you can assign multiple variables, right? Even if like when we'll discuss functions and function return, let's say 5 values. So we can have on the left hand side 5 variables and the function name on the right hand side, and the function returning the 5 values, and those are going to get assigned in that sequence from left to right. the first value to the first variable, second value to the second variable, and so on and so forth. Yes, obviously, if there is some predetermined type, and there can be some error. Otherwise, you will find that this something which is like very intuitive, straightforwardly, one can understand what is going on, right? Similarly, the following cell, where a1 equal to a2 equal to a3 and finally equal to 9. So all these variables a1, a2, a3, a4, they have been assigned value as 9. Right. Those who are familiar with C or Java language, they might have solved this problem, right? If you have some programming experience, this is typical of like a programming swapping, right? Swapping two variables. That a variable A is having 20 and B having 30. So you want to take these two values and you want to swap them. That means you want that finally A should have 30 and B should have 20. So your results should come out like A is storing 30 and B is storing 20. And I'm sure that those who have worked in C or Java or anytime, they have written some good size of code, right? Using another variable, where temporary variable, where to store the intermediate data and then making the swap possible. But here you can see like how simple this can be done, right? So you can see here we have got variable 1. Well, 1 is 90, well 2 is 34. And now what you would like to have, like well 1 should have 34 and well 2 should have 90, right? So this is just a print statement which will show that what is the current value of well 1 and well 2. And then what we did is like this multiple assignment statement, which we have seen in the previous cell, right? So well 1 and well 2 assign well 2 and well 1. Something very interesting, though very simple, but people who have some programming experience, they may get puzzled that how it is happening, that how these two variables are getting exchanged. And the people who are new to this programming, they will understand very straightforwardly that well 1 is getting the value of well 2 and well 2 is getting the value of well 1. Because you see, when we have this multiple assignment statement, then the values assigned from the right hand side to the left hand side in that sequence, right? In that order only. So well 2 will be assigned to well 1, and well 1 and well 1 will be assigned to well 2. And that's what you wanted, right? Exchange. And if you run it, you will get this. The same print statement which given 90 and 34. Now this time it is given 30 and 90, 34 and 90. You see, just one liner, and which will cause in this swap possible. Something which is again a very exemplary example for those who have C or Java experience, that how simple way like this Python can do this kind of job. There is some more printing with this print function. So this is like, so you see, you can print, you can have the printing done in very different ways also. I'm depending upon what your intentions are. So for example, if you want to print this name and age of this person, so print, so you know, you can pass multiple values in the print statement. So this is one string, and then we have this plus sign, which is perfectly all right. You can add to a string, and which will remain a string. So then this is the name, which is another string here, and then we have got this another string, and then we have got this plus, and then we got this age, and age is not a string. I hope you understand that age is not a string, because age by this dynamically typed, it is nothing but integer, right? So what do you think? Should this will work? This statement. What do you think? No, it will not work. It will not work. If I run this, it is going to give me error. And why this is error? Because you see this plus sign, what we are doing, like we are overloading this plot. Means we are using this plus with integer data, So this is one integer, this is second, this name is a string, this is another string, right, with a gap, that's fine, but then this is integer. So that's the problem, like three of them are strings and the one of them are, see, this plus is for use here throughout for concatenating, adding this string, joining this string, right? And this is, so how can I do that? Just convert typecast is str, and this time we will find that, yeah, we will be done. Now that's fine. I mean, this is showing me no error. And for all other also, you can see this is another way. This is the variables we have into percentage s, which is string for s stand for string, d stand for decimal. So that is like percentage d. So we have put this percentage s and percentage d here, which is placeholder. And then after the end of this, we put this percentage, and then within this bracket, we will putting the data in that sequence. So whatever is the data that we have put, they are going to get substituted here on this placeholder in that sequence, right? So Jubin will come first here, and rightly will replace this part, and 34, which is integer, will come here, which replaces this part. And this is another one is like using this format method. So this is a string here. This is a whole string. You can see one single string. Dot format is when we put a dot here, that means we are actually now interested to use a function. Dot is an indication of association with an object. Here it is a string. So dot, if I put dot, that means it I'm associating this string with some function probably, and this is the function format. So this is the function format, which is a function defined on string, right? And that's why this is applicable here. That I put a dot, and I can use a format which is already there, and then I'm passing these parameters. Right, first is Zubin and 34, and they parameters will be taking in that sequence these placeholders. So this is another way of like printing the, and you can see like we can use this f strings, which is like f string, where you can use curly braces to put the variable name, and they will be substituted because they are already defined earlier in the program. So they will be taken, they will be substituted here. So these are different ways of like you can stick to one or two ways, whatever ways you would like to. I mean, just for the sake of having some flexibility of writing or displaying information on the console, you can use this any of this print method. When we say variables, and there are keywords also, right? Keywords are some specialized specialized terms which are meant for special purpose things in the language, right? Now, for every language has their keywords, so the Python also have keyword, and you know that, for example, when we'll discuss this, like if, else statement, else if, elif, the kind of like or other for, or any other like kind of like tokens or terms which have some specific meanings, right? So which cannot be used, these words cannot be used as an identifier or cannot be used as a variable's name. So there you need to be, interestingly, you see integer, if I run this, it will not complain. So integer is not a keyword here. But if I use this and, so that is a keyword here. So you need to know about like what is a keyword. I mean, normally people will assume that, and that's since it is a keyword, so it will say that there is a syntax error, or we cannot print this and. So why? Because and is a keyword. So you should be familiar with that the variable name, though you can define, that's quite a programmer choice, developer choice to give the name of this variable. And the best practice is to give sensible names, though they may be slightly longer, to figure out that what the purpose of this variable or the function is. You can give the name to the function also as per your wish. But what we try to do is like we try to give those names which makes sense, right? And we should not mix them with the keywords. So here, if you would like to see what are the keywords, you can use this this keyword library, and you can use this function. So this is like keyword package or a module rather. A package is collection of modules. So this is a module which is nothing but a file of Python functions. So key w list is a function defined within that keyword module, and therefore and what this function does, this function will return the values of keywords. So when you run this, you will get this list returned. This list contains all these names, all these terms which are actually a keyword, and therefore when they are keyword, you cannot use them as an identifier name or variable name or function name, right? Because they have got their specific meaning. And this import command is, so this at the same time what I've given you an idea of how we can import. Import means bring some code from outside without you actually coding for it, right? Simply importing them and using that. So for example, this key w list function, this particular, in fact, it's an attribute rather than it's basically a list rather than function, because if it would have been a function, then with this kind of bracket and argument, but this is not a function. So what it is in this keyword module, it is a variable, right? It is basically a variable of which is inside that keyword module, right? And what kind of variable it is? It is list type. So when you have associated this dot and call this key w list, what it displays, this key w list, which is a list inside this keyword module, right? So that is what you get list displays. I mean, it's a good number of like words reserved for some specific purposes. So those are called keyword. Okay. Some other variables can be like Boolean variable, where we know the Boolean variable can take two values, 0 or 1. And typically in programming, they got true and false. So you can see here we have got, let's say, not 0. So not 0, 0 is considered as false, and not 0 is going to be true. So when you print this, you're going to get this as true. Right, and what is the type of this variable? Variable 4 is not integer, neither string or any other type, but Boolean, right? Because when we have used this not, this is a logical operator, a Boolean operator, and not with an integer here, which suggests that out of this, so it's perform a logical operation, and you know the results of logical operation is a Boolean value, whether it's a true or. And that's why the type of this Boolean variable is a Boolean, right? That's what you can see, right? Let me quickly go through the basic control flow construct in Python, and they are very similar to any other language. For example, if statement, simple if or if else, or nested if statements. So those kind of, you know, that when you want to check some condition, and so if you want to say that if condition A, then do something, right? If condition B, then do something else. If condition C, do something else. So these structures, which are like control flow structures in programming language, and typically these are available in any programming language. One statement that we have seen is assignment statement. This is one fundamental statement in programming language. Is available in all programming languages. Similarly, the second one is this decision statement, right? Which is like the if statement, right? That's control flow statement that decides that whether this part of the program will be executed or will be skipped. So this if, that is, if some condition holds, then do something, else do something else, right? So that means if condition will hold, then it will do the true part of that condition if the condition is evaluated to be true, and it will not execute the false part. So you see that it will decide. So it's like decision statements, right, inside the program, and they are very fundamental building block for problem solving programming. This is the second fundamental block, structure or statement in programming language that are very useful, right? So simple if will have only if statement. You can have if else statement. For example, if you have this if false equal to true. Now this is the structure of this if statement. Please mind that we have got if. This is a keyword, and then we have this false. It's also a keyword, but false means it's a boolean. And double equal is like comparison operators, right? So we are checking whether the left hand side is equal to right hand side. We are not assigning it, right? Assignment statement is single equal to operator, whereas the double equal to is comparison operator. There, here we are not assigning true to this false. What we are doing that whether the left and right side both are equal or not. So false equal to true, obviously not equal. So you see this part, these three statements here, print this, this, they are the part of this true statement. When true statement, when this part, that is the condition, is evaluated to be true. So this is the condition to be evaluated as true. So these are all these statements. These three are nothing but the code block which will be executed in that sequence, obviously, but they all will be executed one by one. And that is the part when the condition is evaluated true. But as you see, this condition is not true because false equal to true. It's false, right? So when it is false, that means this condition is false. That means this block will not get executed. What is going to get executed? The else block. Because if this condition turns out to be false, then the control of the execution will transfer to else block if it is there. If it is not there, undo anything. I mean, whatever next statement is, it will go and execute that. But if we have used this else and if else statement, so this is the if component of it, if part of it, and this is the else part of it. And mind this semicolon here. There's one thing that this suggests that this from there onward, what part is start? The part where the condition is true is going to get started. And here, after else, there is a column. What it suggests that what part, when the condition is the deciding condition is evaluated as false, then the following code after this is going to get executed. So you see, we got two code chunks, and depending upon certain condition, one of them is going to get executed. We are using if else construct, if else statement, right? There's another thing that you need to remember. I mean, this is very important to understand that how do you know that if the true part of that is the condition evaluated to be true. So what is the block? I mean, what size of this block it is? How many statements are there in that block? So one statement, two, three. Now, how you will say that there are three and not two, or not just one? See, all those statements aligned in this vertical line. See, Python is a block structured language, just like C or Java. Now, here the blocks, there is no separate marker for the block, unlike in C or Java, where we use this curly braces. You know, we have used curly braces, and then there will be statements, and then we'll say that this is one block of statements, right? Here, this is like three statements. These are nothing but one block of statement. How they form one block? All are aligning in the same line. So this is again a kind of like intuitive idea. Like rather than putting some more characters and I mean trying to connect whether they are, I mean if there are nested this braces, curly braces, then which one is opening and closing, right? So people struggle, right? Sometimes they are not placed correctly in this program by the programmer, and there can be many number of like these blocks, and there is like this life is like become difficult. So this idea was like simplified in this Java, in this like Python, and what you should be remembering or be clear about that the tab. So one tab will, so all this statement in one tab, after one tab is like forming this block. So if you don't want any particular statement not in that block, just don't keep in aligning with the other statement in that block. And similarly, after else also we have got one tab. Now, if you want to have like some more statement uh, here in this block, you can write some more statement, 3, 4, 5, any number of statement you can write. This block size can be anything, but just a vertical alignment, and not just in this um, conditional statement or decision statements as we have discussed, but you will find that wherever we are dealing with blocks, right? Grouping a set of statement as a block. Block is a group of statement which where all the statement in that sequence will be executed either all of basis or none basis, or none of them will be executed. So one block of a statement. Right? These are typically useful in organizing your logic. That when your logic are more complex, that you need to write more number of statements in that block, and that block to be executed all at once or none of them. So this there we need blocks, and therefore you'll find that all those general purpose languages, they are block structured languages. And but here in this Python, making of these blocks are straightforward. You want to have like nesting of if statement or nesting of blocks, that is also possible. Give one more tab, and all those statement aligning aligning that tab will be another block. So this block, you should be aware of that, how we create blocks inside Python, and how when we read the code, then what statements together form the block. That is, by looking at the code itself, you can figure out that this is a block. Now here we are using another if statement, but it's a if, else if, and else. I mean here we are actually evaluating three conditions, not just two conditions, right? So basically what it's saying that if num equal greater than 0, if this is true, then print this. You see that there is a tab, and so this is the statement inside the true block of this if condition, right? This conditional expression, conditional statement. Here, this is another conditional statement, else if. So elif is the short form. This elif is a keyword. What it say? That if this is not true, then the control will go the elif part, and then it try to validate. If num equal to 0, both are equal, left and right side, then it will print 0. If this condition is also not true, then it will come this third one. So we may have any number of elif, just like we have one elif here. You can put more elif if you want to actually do a more complex kind of decision making and comparison, so that we can put one after another these elif statement, and then finally there will be a else statement. What it says that if none of them are like evaluated, then finally what can be done, right? So just like here we are trying to suggest that whether the number is positive or 0 or negative, and a number can have three classes. Either it is a positive number or negative number, or the number can be 0 also, like it not belonging to positive or negative. So three classes. So here you can see like this simple code is checking the number is greater than 0, then it is a positive number. That's true. Number equal to 0, it's a 0. The number is, if it is not positive, And if it is neither, it is 0. Obviously, I mean, we don't have to check, though somebody can put a check here also if number is less than 0. But you see, slightly smarter idea is like, because if it is, they are not positive, negative, and they are negative. So they're not positive and 0, so they are negative. So just like a logic that is. And there is some more code, some more example here, a small code to test whether which number is the greatest number. So given 3 numbers, right? So which is the greatest number? Now you can write a code. You can first decide yourself that I will compare first 2 number, and whichever is the greater, then I will compare that greater number with the third number. And if the first number is greater than the third number also, then it is the greatest number. So same logic is like is being played here. If A greater than B, the final result has not come because we have just decided A greater than B. That means if this is true, that means A is greater than B. So that means that control will come here if A greater than B. Then we are also checking whether A is greater than C or not. If A is greater than C also, then the control will come in the true part of this expression evaluation, this condition evaluation, and what we will claim that A is greater than, or I mean, A is greatest, obviously. And if not, then since we know that since A is greater than B already, so B is already ruled out. Now it's a question of like A is greater or C is greater. So if A is greater than C, if this is not the case, then we know that it is C which is greatest because A is already like is greater than B, right? From the first if statement. So you can see like we have got 2 statements, and you can see the alignment also. Within this if, we got another if. So this if is with like inside this if statement. This is nested if, right? So this alignment need to be taken care of. I mean, otherwise your code may not run correctly, right? So what it says that if A greater than B, then we want to go further in the true part. So that nothing but the code of true part of for this first if statement start here and it start with another if statement. That's fine. And that if A also greater than C, you know you got the answer. The A is greater. Or if not, then you got the answer is C is greater. But if A is not greater than B, that means else part of this efficiency. Just see the alignment, vertical alignment, right? You see, we got if, so the corresponding else. So if this is not true, then the control will come here. Here means this else part, and this will start executing, right? So if B, so we know that from this, if it is false, then we know that B is greater than A. So now we have to compare B with C. If B is still greater than C also, then B is the result or C is the result. You can see like this if and else is like they are coming in this like vertical alignment. So this if else measurement, there's another if else statement, and then we have this outer if else statement. The simple logic, but then you need to be a little careful when you put when you use multiple if statement. The correspondence between if else or elif, if the elif is to be also used, they need to be correctly placed. That's important. So I think let me there's some example here. I hope that you can go ahead with that. There's some typecasting example also. And then we have this looping construct. So I have told you one is assignment statement, which is more one of the fundamental programming construct for writing program. Second is if statement, it's like this decision statement. The third one is looping. Once you have these 3 statements, you can write any kind of program. I can tell you, right? These 3 are the very fundamental or the most fundamental programming construct, and the 3 are available in all programming language. Whatever programming language you use, you will find that these 3 are available. Why they are available? Because obviously I'm not going to establish that. Our researcher has already established that these are the 3 fundamental programming constructs to code any kind of logic which can be coded, right? So all these languages, whatever languages you might have been knowing about, any other than Python, Java, C, C++, C Sharp, any other special language also, you will find that they also have these three statement: assignment, decision statement, and looping statement. Now this looping construct, let me finish in a couple of minutes, and then we will take a break and we'll start second session. So you see we have got this for loop here, which so looping is like you want some statements, one or more number of statements to get executed multiple times. You might be looking for something, right? So you done once, you done second time, third time, but it didn't happen. But it may happen fifth time or sixth time, or maybe God knows number of times. So you would like to do it again and again. So for many reasons, right? Sometimes what happens, we are dealing with a group of data. So we have to, and dealing the same idea, I mean, applying same operation for all the elements of that group or the collection, right? So we have to iterate, we have to looping over all the elements of that group, right? And apply that operation. So looping is very fundamental construct. It's a very useful construct, obviously, which where we will loop over some code statement, and that those statements are executed multiple times. So for example, we have got this for loop. There are two kinds of loop here in this language, Python language: for loop and while loop. They are typically available for other languages, whether C or Java. There is do while loop in Java and C, but then it is not there in Python. But it's a very simple, just 4 or 5 lines of code where you can also manipulate do while loop using certain construct. So that's not a problem. So these two loops are very fundamental loops. For loop, for is generally used for when you know that something is to be done some known number of times, right? So some predetermined times this loop is to go. Typically we use for loop, whereas we use while loop until certain conditions remain true. As soon as the condition remains false, we come out from the loop. So these two loops are basically two different purpose, though the capability is same. I mean, we can, if we can do something using for, we can do it using while, and if we can use something with while, we can do it using for also. I mean, but then typically to enhance the code readability, so that one can understand that here when we need to loop over, iterate over some number of statement, we know it up front, so we use for loop. And sometimes we are not sure. I mean, it can be once, it can be done also, it can be maybe a million times. So nobody knows. So that's the kind of way we use while loop. So that helps us to quickly understand the context and to read the code. That's why we use these two different kind of loops. But otherwise, the idea is same, that the underlying statements in those loops will be executed some number of times. Right? So, for example, this for loop, for because the structure or the syntax of this for loop is like this: for ITR is a variable, ITR in a keyword which suggests the range. So the range is a function which is very popular in Python, range function. And what it does, it takes any number of, I mean, it can take one argument, it can take two arguments, it can take three arguments. That's very interesting, a function taking different number of arguments, and you can still use this function. So here it is with three arguments. So what it suggests, like starting value 0, ending value, which is uninclusive, 10. So 10 means before 10. So it will start with 0. The first value, ITR, will take value 0. And the last value will be less than 10. And the increment is in 2. So next time the ITR will be increased by 2. So it start with 0. Next time its value will be 2 in that loop. Next time it will be 4 and 6 and 8. But it will not going to take the value 10, right? Because 10 is the termination condition. So that one you need to be very careful here, that it will not go up to 10, ITR equal to 10, rather than it will go up to ITR equal to 8. 10 is not included, right? So that's what, when you run this loop, so what is it doing? This statement print, again, see the vertical alignment and see that it is not, it is here, right? In the one tab, right, after inside the for. So that is the within the for loop. If you keep it here, just keep it here, and you'll see that this is outside of this for. So you have to use a tab so that to ensure that, to suggest that this is inside the for loop, and therefore this statement will be executed those number of times for which this ITR will be evaluated. So ITR will be evaluated how many times in this range? It will start with the value 0 in the first loop, then it will be incremented by 2, next value will be 2, next value will be 4, and what is the termination condition? If it reaches 10, I mean, so 10 will not be included. So there it will terminate, right? So it is increasing, and there is a like a ending value. So just before this, it will terminate. It will complete its execution. So this statement, which is inside for, will be executed how many times? 0. Then next for 2, ITR equal to 2. Next ITR equal to 4, and then ITR equal to 6, and ITR equal to 8. And then it will terminate. Terminate means this part of the program is completed, right? Otherwise, it is got executed, and we got this 5 print statements, right? For 0, 2, 4, 6, 8. They got printed here with this value of ITR. Right? So ITR is taken initially 0 value. That's what is printed. Next time it is taken value 2. So that's why it is printed 4, 6, 8. So you see, this is how this loop. And similarly, while loop also like what it's saying that we start with a, let's say, variable 4, value equal to 4, and until this variable value, that is value become 10, it will continue. So until till it is less than 10, this will continue. So value is less than 10, yes, because it is 4. So this will be executed, and once this all these 2 statements executed, then the control will come back here. And now value is 5, because the last this statement was value equal to value plus 5. So now value is 5. 5 is still less than 10. So again it will execute. And 6, 7, 8, 9. So value 9 is less than 10. Again it will execute it. As soon as value become 10, 10 is not less than 10. So this will be false. And when it will be false, it will come out from this loop. So you can execute this, and you can see that all these values 4, it started with 4 and up to 9, all these values got printed in this. So you see the loop statement. I mean, those we have taken simple examples, but idea will remain the same. What we want is we want to do something a number of times, right? So you need to put them into either while loop or for loop, depending upon what is the position there. If we know the fixed number of times, we know that this number, we may use for loop. If we know that some condition till that reach, we need to loop, then we can use while loop. And how do while loop can be put in Python? You know, syntax of do while loop is like this. Start with do, and then since this looping construct is not there in the Python, there is a way around, just a small way around, which will suggest that we can actually implement do while loop, where this condition while when it is false, then the loop terminate. So here, rather than checking at the top when the loop enter, we are checking at the bottom of this loop. That's the difference between do while and while do. And here, that is taken care by this if statement, that if this condition becomes false, it is breaking. This break is again a keyword. What it says that it is breaking the loop. Okay. So let's stop here. I've overrun a little just to make the idea of the basic construct in Python to our discussion on those constructs completed. I hope that probably you understood those who knows, they already know it, what I have discussed, but then those who are new or relatively not much exposure, they will understand the difference between all this construct, the importance construct, and now we are ready to go. And we'll learn some more, little more involved stuff like some more advanced data types like list, tuples, dictionary, and then also files. Since we, in a data science course, we will be dealing with files, reading the data from the files, performing operation on the data and all that kind of thing. So that I'm going to cover in the second lecture. I'll start with the list and tuples and those things. Okay, so let's break for half an hour. We will meet at 15:45. Is it fine?
Yes, sir. Is it fine? Because it is already 3:15.
3:15.
Yes.
3:15. So
Yes,
we'll
yes,
meet
yes.
at. So we'll meet at. 15-minute delayed for the stipulated time for the next lecture, which is we'll meet at 3:45. Okay.
Yes, sir. Yes, sir.
Okay. Thank you.
Thank you so much, sir, for a nice lecture.
Thank you.